Hello, friends. Welcome to Learning Nails and Aesthetics. We are starting Chapter 7, Electricity and Electrical Safety of the Milady Foundations book. Learning Objectives. After completing this chapter, you will be able to explain electricity and electrical safety, outline electrical theory, practice electrical equipment safety, identify electrotherapy modalities, discuss light energy. Explain electricity and electrical safety. You decided to enter this field because you love beauty and wellness and all of the services it offers to clients, from hairstyling and hair coloring to facials, massages, and nail wraps. How many of these services would you offer without using electricity? As you study this chapter, you will learn how important it is for beauty professionals to have a basic working knowledge of electricity. Beauty professionals should study and have a thorough understanding of electricity because beauty professionals rely upon a variety of electrical appliances. Knowing what electricity and electrical safety devices are and how they work will allow professionals to use their tools wisely and safely. A basic understanding of electricity will enable them to properly use and care for their equipment and tools. Electricity use impacts other aspects of the salon, spa, or barbershop environment, such as lighting and the temperature or heating tools, and the temperature of heating tools. It impacts all of the services beauty professionals offer their clients. Advanced electrical and light therapy machines require a foundational understanding of electrical theory to be operated safely and effectively. Outline electrical theory. If you look at lightning on a stormy night, what you see are the effects of electricity. If you plug in a poorly wired appliance and sparks fly out of the socket, you will also see the effects of electricity. You are not really seeing electricity, however. Instead, you are seeing its visual effect on the surrounding air. Electricity does not occupy space or have mass, which is weight. So it does not matter. If it is not matter, then what is it? Electricity is the movement of electrons from one atom to another along a conductor. Electricity is a form of energy that, when in motion, exhibits magnetic, chemical, or thermal effects. An electric current is the flow of electricity along a conductor. All materials can be classified as conductors or non-conductors depending on the ease with which an electrical current can be transmitted through them. A conductor is any material that conducts electricity. Most metals are good conductors. This means that electricity will pass through the material easily. Copper is a particularly good conductor and is used in electric wiring and electric motors. Pure distilled water is a poor conductor, but the ions usually found in ordinary water, such as tap water or a river or a lake, make it a good conductor. This explains why you should not swim in a lake during an electrical storm. A non-conductor, also known as an insulator, is a material that does not transmit electricity. Rubber, silk, wood, glass, and cement are good insulators. Electric wires are composed of twisted metal threads, the conductor, covered with a rubber or plastic coating, the non-conductor or insulator. A complete electric circuit is the path. Now I have the hiccups. A complete electric circuit is the path that negative and positive electric currents take from the generating source through the conductors and back to the generating source. Types of electric current. There are two types of electric current. Direct current, abbreviated as DC, is a consistent, even flowing current that travels in one direction only and is produced by chemical means. Flashlights, cell phones, and cordless tools use the direct current produced by batteries. The battery in your car stores electric current. Without it, your car would not start. An inverter is an apparatus that changes direct current to alternating current. Inverters usually have a plug and a cord. They allow you to use appliances outside outside of your salon, spa, and barbershop or home that normally would have to be plugged into an electrical wall outlet. The phone charger in a car is an example of an inverter. Figure 7.1 is a picture of a complete direct current, which is DC electric current. Alternating current, abbreviated as AC, is a rapid and interrupted current flowing first in one direction and then in the opposite direction. It is produced by mechanical means and changes directions 60 times per second. Corded hair dryers, curling irons, electric files, and table lamps that plug into a wall outlet use alternating current. A rectifier is an apparatus which changes alternating current to direct current. Cordless electric clippers and phone chargers use a rectifier to change the AC from an electric wall outlet to the DC needed to recharge their batteries. Table 7.1 outlines the differences between direct current and alternating current. Direct current is a consistent flow, while alternating current a rapid and interrupted flow. Direct current travels in one direction. Alternating current travels in two directions. Direct current produced by chemical means. Alternating current produced by mechanical means. Electrical measurements. The flow of an electric current can be compared to water flowing through a hose. Without pressure, neither water nor electricity would flow. A volt, abbreviated as V and also known as voltage, is the unit that measures the pressure or force that pushes electric current forward through a conductor. Car batteries are 12 volts. Normal electric wall sockets that power your tools are 120 volts. Most air conditioners and clothes dryers run on 240 volts. A higher voltage indicates more power. An ampere, abbreviated as A, and also known as amp, is the unit that measures the strength of an electric current. Just as a hose must be large enough to carry the amount of water flowing through it, a wire must be large enough to carry the amount of electricity, amps, flowing through it. A hair dryer rated at 12 amps must have a cord that is twice as thick as one rated at 6 amps. Otherwise, the cord might overheat and start a fire. A higher amp rating indicates a greater number of electrons and a stronger current. Amps measure the strength of the electric current. A milliampere, abbreviated as lowercase m, uppercase A, is 1 in 1,000 of an ampere. The current used for facial and scalp treatments is measured in milliamperes. Milliamperes. An ampere current, which is much too strong, is used for facials and scalp treatments. An ampere current would damage the skin or body. An ohm, abbreviated as O, is a unit that measures the resistance of an electric current. Current will not flow through a conductor unless the force, volts, is stronger than the resistance, ohms. Did you know 1 kilowatt hour will power a television for 3 hours, run a 100-watt bulb for 12 hours, and keep an electric clock ticking for 3 months? A watt, abbreviated as W, is a unit that measures how much electric energy is being used in 1 second. A 40-watt light bulb uses 40 watts of energy per second. A kilowatt, abbreviated as lowercase kW, is 1,000 watts. The electricity in your house is measured in kilowatts per hour, lowercase kwh. A 1,000 watt, 1 kilowatt, hair dryer uses 1,000 watts of energy per second. Check-in. Define the two types of electrical current. Practice electrical equipment safety. When working with electricity, you must always be concerned with your own safety, as well as the safety of your clients. All electrical equipment should be inspected regularly to determine whether it is safe working order. Careless electrical connections and overloaded circuits can result in electrical shock, a burn, or even a serious fire. Safety devices. A wire that is not large enough to carry the electrical current passing through it will overheat. The heating element in a hair dryer or curling iron heats up because it is not large enough to carry the electric current. Heating elements are designed to overheat and are safe when used properly. However, when the electrical wires in a wall overheat, they can cause a fire. If excessive current passes through a circuit or a fuse, the circuit breaker turns off the circuit to prevent overheating. These are the electrical safety devices that you may encounter when working in a salon, spa, or a barber shop. A fuse prevents excessive current from passing through a circuit. It is designed to blow out or melt when the wire becomes too hot from overloading the circuit with too much current, such as when faulty equipment or too many appliances are connected to an electric source. To re-establish the current, disconnect the appliance, check all connections and insulation, insert a new fuse, then reconnect the appliance. Fuses are often found in older buildings that have not been renovated or modernized. A circuit breaker is a switch that automatically interrupts or shuts off an electric circuit at the first indication of an overload. Circuit breakers have replaced fuses in modern electric circuits. They have all the safety features of a fuse, but do not require replacement and can simply be reset by switching the circuit breaker back on. A hair dryer has a circuit breaker located in the electric plug that is designed to protect both professional and client in case of an overload or short circuit. When a circuit breaker shuts off, you should disconnect the appliance and check all connections and insulation before resetting it. Grounding. Grounding completes an electric current and carries the current safely away. It is another important way to promote electrical safety. All electrical appliances must have at least 2 rectangular electrical connections or prongs on the plug. This is called a 2-prong plug. The 2 prongs supply electric current to the circuit. If you look closely at the 2 prongs, you will see that one is slightly larger than the other. This guarantees that the plug can be, watery eyes, sorry. This guarantees that the plug can be inserted into the outlet only one way and protects you and your client from electric shock in the event of a short circuit. For added protection, some appliances, especially one with metal casings, have a third circular electric connection that is a grounding pin. This is called a 3-prong plug. The grounding pin is designed to guarantee a safe path of electricity and protect the user from electrical shock even if a wire comes loose. Appliances with a third circular grounding pin offer the most protection for you and your clients. Ground fault interrupters. A ground fault interrupter is designed to protect from electrical shock by interrupting a household circuit when there is a leak in the circuit. GFIs are required by the electrical code for receptacles in bathrooms, kitchens, and some outside receptacles. A GFI is designed to detect currents of a few milliamperes and trip a breaker at the receptacle or at the breaker panel to avoid a shock hazard. When it's working properly, a GFI has a green light that turns red when it trips. Once the appliance is removed from the socket, it can be reset with the reset button on the panel. Underwriter Laboratories. Underwriter Laboratories, UL, certifies the safety of electrical appliances. Curling irons, hair dryers, electrical clippers, UV lamps, pedicure chairs, heating mitts, electric files, and more should be UL approved. This certifies that they are safe when used according to the manufacturer's directions. Always look for the UL symbol on electrical appliances and take the time to read and follow the manufacturer's directions. Activity: gadget inspection. Inspect any electric items in your kit or equipment in the classroom for UL approval. Also look at any labels, precautions, and warnings on these tools and take notes of what you find. Discuss your observations as a class. Guidelines for safe use of electrical equipment. Shop fires are often caused by electrical problems, such as shorts in the wiring of the building or improper use of appliances, extension cords, and plugs. Careful attention to electrical safety involves following recommended UL guidelines, manufacturer's directions, and the safety instructions and policies of your establishment. The guidelines below will help you use electricity and electrical equipment safely. All of the electrical appliances you use should be UL certified. Read all instructions carefully before using any piece of electrical equipment. Always register electrical appliances with the manufacturer so that you will be notified of any safety recalls immediately. Disconnect all appliances when not in use. Pull on the plug, not the cord, to disconnect. Disconnect all electrical appliances prior to cleaning them. Never poke hairpins or wires through any part of an appliance, including lint screens. Inspect all electrical equipment regularly. Keep all wires, plugs, and electrical equipment in good repair. Do not use cords that have exposed wiring in any part of the cord or where it attaches to the appliance. Use only one plug in each outlet. Overloading may cause the circuit breaker to pop. If more than one plug is needed in an area, use a power strip with a surge protector. One moment, please. I need a drink. Avoid contact for both you and your client with water and metal surfaces when using electricity, and do not handle electrical equipment with wet hands or while standing on a wet floor. Keep electrical cords off the floor and away from everyone's feet. Getting tangled in a cord could cause you or your client to trip. Do not leave your client unattended while the client is connected to an electrical device. Do not attempt to clean around electrical outlets while equipment is plugged in. Do not touch two metal objects at the same time if either is connected to an electric current. Do not step on or place objects on electrical cords. Do not allow electrical cords to become twisted. This can cause a short circuit. Do not alter a three-prong plug to fit into a two-prong outlet. Do not attempt to repair electrical appliances. If you have a problem with electric wiring or an electrical device or appliance, tell your supervisor immediately. Take the device to a repair store or call a certified electrician or repair representative to resolve the issue. If you see sparks when plugging or unplugging an appliance, do not use the appliance or outlet until it has been approved by a certified electrician as safe to use. Verify regularly that fire extinguishers are appropriate for electrical fires, are not expired, and that you are comfortable when using one. Remove lint from clothes dryers before each load to reduce the chance of fire. Activity: hazard sweep. Evaluate the electrical safety of your home or classroom. What safety devices can you find? GFI, circuit breakers, surge protectors, etc. What are some potential hazards? How might you address or minimize the electrical hazards? Share your findings as a class. What to do in an electrical emergency. Virtually all electrical incidents in a salon, spa, or a barbershop environment will be related to low voltage, less than 500 watts appliances. Low voltage shocks are rarely critical, but they can be quite painful and dangerous to some individuals. It is important that you take signs of wear and tear seriously and replace or discontinue using appliances or outlets as soon as you notice these signs. If you receive a light shock sensation while using, turning on or off, or plugging or unplugging an electrical appliance. Stop using the appliance immediately and turn it off completely. Unplug it from the wall or turn off the circuit breaker to that outlet. Replace the appliance or have it repaired by an authorized repair representative. If similar issues occur with other appliances in the same outlet, discontinue use of that outlet until approved by a certified electrician. If you drop an electrical appliance in water. If the outlet is GFI protected, it will kill the circuit immediately, and you may unplug the appliance from the wall after releasing the appliance. Do not have one hand in the water and one on the outlet. If the outlet is still live, your body will conduct electricity. If the outlet is not GFI protected, go to the breaker box and flip the circuit off. If you are unsure which circuit controls that outlet, it is better to momentarily shut off power to the entire shop while you fix the situation. Once the power is off, unplug the item and then restore power. Never use an appliance that has been dropped in water. When to seek medical care after an electrical shock. Anytime during pregnancy. If you have burns on the skin, particularly those that are open or do not heal well over time. If you are not current on your tetanus immunization, given every 5 years to adults, check in. What are at least 5 steps to take for electrical safety? Identify electrotherapy modalities. The use of electrical currents to treat the skin is commonly referred to as electrotherapy. Current used in electrical, facial, and scalp treatments are called modalities. Each modality produces a different effect on the skin. An electrode, also known as a probe, is an applicator for directing electric current from an electrotherapy device to the client's skin. It is usually made of carbon, glass, or metal. Each modality requires 2 electrodes, one negative and one positive, to conduct the flow of electricity through the body. The only exception to this rule is the Tesla high-frequency current, which uses a single electrode. Caution: older buildings and homes may have 2-pronged wall outlets. Some equipment and tools have 3-prong plugs. Never tamper with the wiring of a building or home wall outlets or plugs to make them fit your equipment and tools. Adapters are available, if it is appropriate for you to use one. Consult the manufacturer and use your local hardware store about whether you can use an adapter, and if so, what type of an adapter is recommended. Polarity refers to the poles of an electric unit, either positive or negative. The electrode on many electrotherapy devices have one negative charge pole and one positively charged pole. The positive electrode is called an anode. The anode is usually red and is marked with a... Oh, I thought I skipped a line, and I did not. The positive electrode is called an anode. The anode is usually red and is marked with a P or a plus sign. The negative electrode is called cathode. It is usually black and is marked with an N or a minus sign. The negatively charged electrons from the cathode flow to the positively charged anode. If the electrodes are not marked, ask your instructor, manager, or supervisor to help you determine the positive and negative poles. We are going to stop right there. We will finish Chapter 7 in some upcoming videos. I am still working on getting together the so many items that I have for unboxing, swatching, and just having a lot of fun with. We will also get into the books from Milady for nails and aesthetics. I am a licensed nail tech and esthetician. So please like, share, subscribe, comment, and join us again for the future videos. I appreciate it. Thanks. Bye.